Hello, my friends. I'm going to do this extra review for you, even though I think you're all going to do so great and you probably don't need it, but I'm going to do it anyway. Okay. So find the product. Product means multiply. So basically, this is really just an application of the distributive property, going to multiply the three terms in the parenthesis by the one term outside. Okay. So 2x times x squared is 2x cubed. I got to get a new pen. I keep saying that every time. 2x times 6x is 12x squared. And 2x times negative 5 is negative 10x. So when you multiply monomials, which this 2x is, anything that's a single term is a monomial, you're going to do the coefficient times the coefficient, so the 2 times the 1. And then with the variables, when you have like variables or like terms, it's keep the base, so keep the x and add the exponents. All right. Now, factoring is fancy division if you want to think about it. And one of the things about that is recognizing patterns. So this is the difference of two squares. First of all, it's a difference because there's a subtraction symbol. It's 2 because 1, 2, 4x squared, 25, two things. And then they're both perfect squares. So when you do that, you take the square root of the first term, which would be 2x. You take the square root of the second term, which would be 5. And then you just make sure that those are additive inverses. So one's a plus, one's a minus. We also call those conjugate pairs. Now remember, you can check all of this, totally check it on the calculator. All right? So we have the square of negative 3x to the 6. Now, one thing to keep in mind is that if it helps you, you can write this out. So you would write negative 3x to the 6 twice. Also, a negative times a negative is always a positive. So I would only be looking for positive answers. So it's positive 9. And then 6 plus 6 is 12. You can also do this using the power to a power rule. So 6 times 2. Power to a power, you would multiply the exponents. Okay, so number 4. I did factor this 3 different ways. Only one of them is completely factored, meaning finished, done, no more common factors. The first one, I pulled out a common factor of 3. 3 is not the greatest common factor because, actually, there should be a 2 there. So this should say 3 parentheses 2x. Minus 18. But anyway, the point is that that is not the greatest common factor. 6 is the greatest common factor. So if you look at the second one, I pulled out the GCF of 6. And that is considered factored. It's just not factored completely. Completely would mean factor till you can't factor no more. Now, if I put all of these, except for the one where I made the typo, into the calculator, they would all be the same graph, the same picture, the same table, because they're equivalent. It's just that only one of them is factored completely. All right, name a common factor. So I'm going to factor the first one, and I'm going to use the X game method. So I'm looking for factors of 10 that when I add, I get a negative 7. So that's going to be negative 5 and negative 2. So that would be x subtraction 5 and x subtraction 2. And again, you can check that on your calculator. So you can use the test button, and I'm going to show you all of that at the end, or you can also use the graph. Now, if I factor x squared minus 25, that's the difference of two squares. So I'm going to have my conjugate pairs, x minus 5 and x plus 5. Or, the positive 5 and the negative 5 are additive inverses. You can look at it, more than one way. And they're saying to name a common factor. So what factor do they both have? They both have x subtraction 5. So that would be a common factor of those two things. Okay, the first polynomial is a trinomial, 3 terms. The second polynomial is a binomial, 2 terms. And the second one happens to be the difference of two squares. Find the square of x minus 3. So that's basically telling me to multiply x minus 3 times x minus 3. So you can write it out, x minus 3 times x minus 3, and do your work that way. Or the answer's gonna be, gotta love it, a perfect square trinomial. So you can also, remember things, remember patterns, remember things. All right, so this is gonna be x squared minus 3x twice, and then a plus 9. And of course, the pen's not writing great. So therefore, I get the perfect square trinomial x squared subtraction 6x add 9. Okay, x squared minus 6x plus 9. All right, factor. Well, that's a binomial, but 5's not a perfect square. So it's probably GCF. They both have a 5x in common. So first I pull the GCF out, and I do that by dividing. Now, this is something that a lot of you kind of struggle with because you're like, you don't like a GCF? I don't know. But so this is something I would totally check. And you can just go back and do the distributive property and make sure that it works. Okay, factoring completely. Factoring completely implies to you that you're going to factor more than once. Okay, so the first thing I would look for is a GCF. And 4 is a common factor of 24 and 64. So I'm going to pull out the 4 by dividing. And that's going to give me x squared adding a 6x and subtracting a 16. So I'm going to keep my 4. And I'm looking for factors of 16 that are going to give me a 6. So I'm going to use 8 and 2, right? 1 and 16 won't work. I'm so sorry about this pen. But 2 and 8 will work. Okay? So that's going to be x plus 8, x subtraction 2. Now, why does it work? Well, positive 2 wouldn't work because if it was a positive 2 and a positive 8, that would add to 10. Negative 8 wouldn't work because that would add to negative 10. Negative 8 and a positive 2 wouldn't work because that would add to negative 6. But positive 8 and negative 2 do work because it adds to positive 6 and multiplies to negative 16. Okay? GCF of 4 again. No, the GCF is not always 4. It just happens that these two examples have a GCF of 4. And then this binomial that's here, that's the difference of two squares. So I'm going to factor that using conjugate pairs. Square root of 16 is 4. So x subtraction 4, x add 4. It's useful to look at patterns. I would totally look back at any of the review sheets that we have and think about like what things look like when they have a greatest common factor. So here's an example of a greatest common factor. If I can write, say I had 2x minus 8. They're both even numbers, so I would pull out the 2, and that would be 2 times the quantity x subtraction 4. I can tell it's a GCF because they have something in common. Okay, the difference of two squares, that's going to look like right here, the x squared minus 16. That's going to look like way back here, the x squared minus 25. Remember, those are perfect squares. The x squared minus 9, the 4x squared minus 25, binomial with subtraction of two perfect squares. Okay. Perfect square trinomials, gotta love it. It's always going to have a perfect square in the front. I wish this pen would write. And then it's always going to have a perfect square at the end. And that perfect square If you take the square root of that and then multiply by 2, that's going to give you the coefficient of your linear term. All right. There is so much that you can Google on this. Lots and lots and lots and lots of things that you can look at. The packet, Google, type it into YouTube, anything Algebra 1 factoring. Let me just show you how to check this stuff on the calculator. Oh, let's see.